Welcome back to iOS Expert. The lecture part of this crash course on unit testing and dependency injection is complete. I hope that you now have a solid understanding of both. But to really grok this material, you must apply it. I will show you 3 implementation functions, each with a depend effect that complicates unit testing. For each, I would like you to complete the following exercise. First, identify the depend effect and state how the depend effect complicates unit testing. Next, write a protocol that enables injection of the depend effect, or change the code to accomplish dependency injection via method injection. Finally, if you created a protocol, create the production and test double conformances. State whether the test double is a fake, dummy, stub, or spy. As I repeat these instructions for each depend effect, please pause the video and take as much time as you need. This is formatter. It has one function, format currency, that takes an int representing hundredth units of currency. The function returns a formatted currency string. On my iPhone and Mac, the input 4200 results in the output $42. What is the depend effect, and how does it complicate unit testing? Please pause the video while you decide. The function has a dependency that complicates unit testing, specifically a dependency on the device's locale. An iPhone running in Wales or France, respectively, would likely experience this output, snippet 87. Because the output can vary so much, making assertions about the output in unit tests is tricky. Now decide whether to use method injection to inject the locale dependency or create a protocol, production conformance, and test double conformance. If method injection, try injecting the dependency yourself. This is formatter with injection. There is no need for state or therefore initialization. Method injection doesn't involve initialization, so I used method injection. Note the default value on the locale argument. Callers need not specify locale, though unit testing callers likely will to ensure consistent output. This is getter-setter. The purpose of this class is to retrieve small amounts of data from, and save small amounts of data to, user defaults. In case you are unfamiliar with user defaults, it's a small database available on all Apple platforms. Many apps use it to save and retrieve preferences or settings data. What is the depend effect, and how does it complicate unit testing? The use of user defaults introduces both a dependency and a side effect. Unit tests can't rely on user defaults starting in a pristine state. If a unit test, particularly one running on the developer's iPhone, writes to user defaults, that write could impact future behavior of the app in production. Now decide how to inject the depend effect using either method injection or a combination of protocol, production conformance, and test double conformance. If a test double is appropriate, decide which type of test double you would use: spy, stub, dummy, or fake. User defaults is inherently stateful. The state is the contents of the user defaults database. A stateless method with method injection would therefore be inappropriate for handling this depend effect. A protocol, production conformance, and test double conformance are the way to go. The type of test double is clear from process of elimination. Users of the test double have no need to peek into the behavior of the test double. That eliminates spy. Users of the test double need some sort of implementation, for example to simulate saving data to and retrieving data from user defaults. That eliminates dummy. Users of the test double don't want to retrieve canned data. They want to retrieve the data they saved. That eliminates stub. The remaining type of test double is fake, a kind of test double that has a real implementation but that takes some sort of shortcut, in this case not involving user defaults. Fake is the right choice for this test double. Now try writing the protocol, production conformance, and test double conformance. This is getter-setter reimagined as a protocol. These function signatures are unchanged, but the implementations are obviously gone. This is getter setter real, the production conformance. This implementation is largely identical to the original, but with two changes. First, for clarity and for consistency with naming in Roman numerals, the class is renamed getter setter real. In other apps, I've used a name like getter setter user defaults for this sort of conformance. This is getter setter fake, the test double conformance. Note the use of a dictionary for the implementation. Like user defaults, a dictionary can support retrieving and saving data, but a dictionary lacks the dependeffect character of user defaults. This is Review Prompter, a greatly simplified version of a class I use in my side project apps. The intent of this class is to prompt for an App Store review after the user has repeatedly taken significant steps in the app. In a note-taking app, a significant step might be saving a new note. App Store reviews help increase an app's App Store search rankings, so a developer might be inclined to immediately request a review on first app launch. This would be a mistake because the user is not invested in the app at that point. An immediate request for a review is therefore unlikely to result in a good review. An app with Review Prompter calls promptable action happened after each significant step the user takes, for example, saving a new note. In this simplified implementation, Review Prompter requests a review after the fifth significant step. By that point, the user is likely invested in the app and therefore likely to leave a good review. What is the depend effect, and how does it complicate unit testing? Review Prompter has a side effect that is undesirable for unit tests. The current implementation actually requests reviews, even in unit tests, potentially exhausting the user's budget of review prompts. Review Prompter has another problem. As with analytics, unit tests should verify that promptable action happened is called at appropriate times and that the appropriate number of reviews are requested. But the number of times that reviews have been requested is opaque to unit test callers. Now decide how to inject the depend effect using either method injection or a combination of protocol, production conformance, and test double conformance. If a test double is appropriate, decide which type of test double you would use: SPI, stub, dummy, or fake. Review Prompter is inherently stateful. Depending on user behavior, a specific number of reviews has been requested. A stateless method with method injection would therefore be inappropriate for handling this depend effect. A protocol, production conformance, and test double conformance are the way to go. The type of test double is clear from process of elimination. Users of the test double need some sort of implementation in order to simulate review requests at appropriate times. That eliminates dummy. Users of the test double don't want to retrieve canned data. They want to retrieve the number of times that reviews were requested, which will vary. That eliminates stub. The original implementation has no output visible to callers, and a fake implementation of Review Requester won't provide callers the information they need about how many reviews were requested. This eliminates fake. The remaining type of test double implementation is SPI, a kind of stub that also records some information based on how it was called. SPI is the right choice for this test double. Now try writing the protocol, production conformance, and test double conformance. This is Review Prompter, reimagined as a protocol. The function signature is unchanged, but the implementation is obviously gone. This is Review Prompter Real, the production conformance. This implementation is largely identical to the original, but with one change. For clarity and for consistency with naming in Roman numerals, the class is renamed Review Prompter Real. This is Review Prompter SPI, the test double conformance. Note the absence of any side effect of actually requesting a review. Imagine that the app being unit tested calls promptable action happened when the user saves a new note or prints a note. In a note-taking app, A unit test could simulate 10 note savings and 10 note printings and use the SPI to verify that 20 promptable actions did, in fact, occur. This approach would be similar to the approach you saw earlier for unit testing analytics, which also used a SPI. This concludes the iOS Expert Crash Course on unit testing and dependency injection. Information about these concepts is widely available in books and on the internet, but I hope my application of these concepts to a real, if contrived app has given you a solid base of understanding that you can apply in future coding challenges and production apps. Here are some resources for future exploration. URLs are below the video player. The Martin Fowler article on test doubles is a great introduction to that concept. When you're showing off your knowledge of test doubles, you'll probably elicit more impressed nods of recognition if you cite him rather than me. He's currently more famous. The article describes the kind of test double, a mock, that you may find useful. I didn't cover mocks in this crash course because I don't use them. Joe Lodi has written a book called Test-Driven Development in Swift, Compile Better Code with XCTest, and TDD. As you can tell from the title, Joe is, unlike me, a practitioner of TDD. I recommend this book for two reasons. First, it covers useful material that I couldn't fit into this crash course. Some examples are the XC test case lifecycle and testing Swift UI views. Second, Joe better conveys the value proposition of TDD than I could, and, if you read this book, you might agree with him that TDD is the way to go. Even if you don't agree with him, you'll be better equipped to explain your reasons for eschewing TDD. If you plan to use the world for dependency injection, as I do, you should read the point-free article introducing it. You'll be better equipped to explain your choice of that approach, because the article addresses certain critiques of it. On the subject of critiques, I do have two of this article. First, the point-free gentlemen explicitly reject the label dependency injection as what the world accomplishes. I disagree with this rejection, perhaps because my personal definition of dependency injection differs from theirs. Second, the article doesn't mention the problem of compilation time that would make the world an inappropriate choice for a huge app. Another reason to read the article is that the point-free implementation of the world differs from mine in that functions, not protocols, lie at the heart, and you may prefer the functional approach. Regarding the problem of compilation time, watch the Bruno Hosha conference talk about Spotify's approach to dependency injection in their iOS app. You may not soon have the opportunity to architect an iOS app as big as Spotify's, but the problem of compilation time could certainly come up during a system design interview for an iOS job. I wish you success and happiness as you test units and inject dependencies.